Hello everyone, welcome to SDNBit. In this channel we discuss network automation and programmability concepts, and in today's video we are going to dive deeper into Arista's VAOS software image, and through this software image we are going to explore possible automation and programmability options for Arista ecosystem. So as you can see on my screen, I have set up a very simple lab topology consisting of 4 switches. I have named them as jewelry, stones, gold, diamond, silver, and bronze. And my gold switch has access to my home network, and through my home network I am able to reach the internet. Now, I have done this because I am planning to create and execute some scripts on my switch for automation purposes, and perhaps I might need to install some packages, and to do that I might need to download those packages from remote repositories. So that's why I might need an internet access. So on the last video I have successfully installed images to my EVNG VM to be able to emulate them in this lab. So if you are interested in how to download, where to find images for Arista devices, just make sure to watch my previous video. And if you actually do that or did that, you remember that at the last part of my video, I have rebooted the device after disabling the ZTP. So let's just proceed from there. I'm going to open up my console session to this switch, which is supposed to be named gold. So I'm just going to maximize the window, and there you go. So suppose that this is after I have disabled the ZTP, the switch automatically rebooted, and now we have this view. So by default, as I have already mentioned in the previous video, Arista devices have the username of admin. Let's just type it in, and there is no password by default. So we're directly going to the enable mode. And from the enable mode, let's just jump into the privileged execution mode. And from privileged execution mode, we can run multiple show commands to see the state of our device. So if I run the show version command, I will see that my software image version is 4.29.6. This is a different device from the previous video, but just for the sake of the diversity, I have decided to include different software image versions on my topology to be able to compare if they have some feature differences during the lab. And there is also another valuable piece of information, which is the uptime for the 6 minutes in this case. Okay, so we're exploring automation and programmability, and we have a fresh switch without any configuration on it. So let's just go ahead and apply some initial configuration to be able to work with our switch in much more facilitated manner. So the first thing I'm going to do is to set a proper host name. I want this switch to be named as gold, so I'm just going to go ahead to global configuration mode. I'm going to issue hostname gold command. Good. Now we have a host name. I would love to have my own user to be able to access this device via SSH or other possible protocols or options. So I'm going to go ahead and create a username of Arista, and the secret will also be Arista to keep things simple. We do not concern ourselves with security threats in this particular case because we're basically running a lab. So the next step would be to assign an IP address to our interface, which is pointed towards the internet, which is my home network, and then the internet. So I'm going to go ahead and make this interface routed. I'm going to turn this to a routed port. I'm going to enable IP routing, which is disabled by default on Arista switches because it's a switch that makes sense. And then I'm going to assign an IP address to this particular interface of Ethernet 8 via DHCP. So let's go ahead and do this. I'm doing this just to be able to connect to the internet, to download possible packages, and also use SSH to connect to my device, which is much more convenient. So let's just go ahead and start with enabling IP routing. To do this, you have to issue IP routing command, and then we can go to interface Ethernet 8. We can disable the switch port mode by running no switch port command, and I am going to assign a DHCP address to it by issuing IP address DHCP command. But before, let's just make sure it doesn't have any IP address on it. So I'm going to say show interface Ethernet 8. And as you can see, no Internet Protocol address assigned. So we don't have an IP address. And let's go ahead and run IP address DHCP command. Let's give it some moment and check. Perfect. Now we have an IP address assigned by a DHCP server. So in this particular case, I should be able to ping my EvenGVM IP address, which is 1.6, because we're running this lab on EvenG. We should have a direct connection to this interface. So I'm going to go ahead and ping 1.192.168.1.6. Perfect. We can ping it. However, we will fail to ping other nodes on my home network because we do not have a route, a static route, configured pointing to my home default gateway. Just to verify this, I will actually ping my own workstation IP address, which is 1.33 in this particular case. As you can see, my Windows 11 machine. And if just to verify the things, I'm going to run ipconfig command right here, and you can see that my IPv4 address is indeed 1.33. So let me go ahead and try ping, which should fail because we don't have default gateway. And that's right. 5 packets transmitted, 100% packet loss. So let's go ahead and configure a static route pointing to my home default gateway. So to do this, I'm going to go back to global configuration mode. I will issue IP route 0/0, and I will issue the IP address of my home default gateway, which is 1.1. After I enter this command, I can run show IP route command to verify that the static route has been properly inserted to our routing table. And if I ping the workstation of mine, the Windows 11 machine, I should be able to ping it. I should be, but I cannot because probably I missed something. So let's just check the running configuration to understand better what's the problem. I have an IP route pointing to my home router. IP routing has been enabled, and the DHCP address has been assigned. But for some reason, I cannot ping it. Can I ping the gateway since I have already assigned the static route? I can ping the gateway, so this is weird. This is weird. I should be able to ping my host as well. Can I ping this interface from my host? That's what we're going to check now. Yes, I can. So I do believe there are some problems with my host's visibility on my home network, which is not a problem at all. It's not important to ping my workstation at all. So I'm going to go ahead and try to ping the internet because from my home router, I can reach the internet. So I'm going to ping the Google's 888 address. I can do that. Can I ping the DNS name, the domain name? I can't. Why? Because by default, we do not have any name servers configured. So let's just go ahead and configure a name server. I will put the Google's default name server. And in this case, we should be able to resolve the google.com domain name to an IP address, which is successful. This is the IP address, and this is the ping result. Perfect. So we can successfully install, download packages from the repositories to be able to use our automation ecosystem much better. So that's great. So now we have sufficient amount of initial configuration to begin exploring automation options in Arista device. So let's just go ahead and, I guess, drop to the documentation where we can understand how to enable or should we enable or disable or should we configure something to be able to use APIs, right? So I'm going to go to Arista's official website. I'm going to go to support and product documentation. Here I should be able to find EOS system configuration guide, which might be a user manual. Exactly, that's what I could need. And in this section, as you can see, you have initial configuration recovery section, which I actually read before recording this video. So if you just booted your Arista device and if you want to apply some recommended initial configuration, make sure to find this web page and follow the instructions to completely configure your device. So in this case, I am looking for something regarding APIs. APIs, and can I see really something? I can see a lot of different sections. Okay, let's just go ahead and see what we have here. So manual provisioning, admin username, we have already configured this. Good. What else? Assigning an IP, we did this by DHCP because we just need one. We configured the default gateway already. Anything else? Not really. So, okay, they haven't indicated here, but maybe if I dig deeper I can find, but I'm just gonna go ahead and show you because I know it myself. At this point, actually, we don't really need the console access, so let me just go ahead to my secure CRT and try to establish a session via SSH to my gold router. So I'm going to hit next. I'm going to indicate the IP address of my gold switch. Username of Arista. Next, session name will be gold. Finish. Try to access. And let's put the password of Arista. Perfect. Now we can successfully access our device via SSH. So I will go ahead and close this console session because it's not convenient. Okay, so we're here, and the command to check whether the Arista's API or eAPI is enabled or not is as follows: show management API HTTP commands. As you can see, it's not enabled, and we don't have pretty much other information. So let's go ahead and enable this. I'm going to say configure management API HTTP commands. We're going to exactly the same section, and under this section you will have multiple commands to run. What we need to do is to enable API access. So basically we're just going to negate the shutdown command. No shutdown, enter, should work now. So if we run this command again, we will see that it has been successfully enabled. That's good, that's good. So apart from this information right here, if you look at the bottom, you will see that there's a URL. Let's go ahead and open this URL. Boom. So this is a page where information about Arista's APIs are illustrated. Basically, it's a quick documentation and interactive tool which will let us to interact with our device via APIs. So let's go ahead and run some commands like show version to see. And if I run this command from here, I should submit a post request and I will get a response in JSON format, by the way. So Arista prefers JSON as a data formatting option. And there we go. We have the show versions output as a JSON format here, which is great because it's structured data and we can manipulate this data and play with it, which is much more efficient. Okay, so don't know where to start, read the API overview or try one of these examples. Okay, let's go ahead and read the API overview actually, which is the same. Okay, we just can go ahead and, okay, go to this section. So this is the overview. The Arista command API is a simple and complete API that allows you to configure and monitor your Arista switches. Okay, that's good. What I'm interested in is on-box usage because I want to execute the scripts from the Arista device itself, right? Let's go to the on-box usage section. And in this section, we have multiple options. So the first option is using eAPI client lib requires no configuration, meaning we don't need any configuration to do this. So let's just go ahead and try to run this script snippet in our device. I'm going to open up Visual Studio. I have a dedicated folder for Arista here. I'm going to create a file named, let's say, test.py, and I'm going to paste the output here. I am going to make sure it's well constructed. Okay, now let's copy this output and let's go to our device, the gold device itself, right? Okay, great. Let's go back and let's drop into the bash of Arista device. Now the bash of Arista device is much advanced and versatile than other vendors because it's not just a stripped version of Linux distro. It's Linux itself, meaning it's very, very flexible and extensible. The Arista's operating system is called extensible primarily because of the fact that you can actually have Linux on your switch, which is amazing if you want to customize your device exactly as per your needs. So we're in the bash. Let's just run some Linux commands to see what's going on here. As you can see, it's a Linux machine. What if I run hostname cdl? Do we have this command here? Yes, we have, sir. It's a computer VM. As you can see, it understands. And the operating system is CentOS Linux 7, which is great. So let's go ahead and see where we are. We are in user directory under home directory, which makes sense by default. It's always like this, almost. So I have to tell you that Arista has only two, let's say, sections on the device where you should put your data, where you are recommended to put your data, to store your data. Those are the drive directory and flash directory. So drive directory is only possible if you actually have an SSD on your box, right? In our case, we cannot talk about this because that's a virtual lab. I don't have any device. It's completely virtualized environment. But if you have hardware and if you have SSD installed on it, this is the best place to store your sensitive data or scripts or whatever you might need on a daily basis, right? In our case, we don't have it, but we have flash directory. Let's go ahead and switch to flash directory. So I'm going to change directory to mount flash, and let's see what we have in this directory. So we have a lot of files here, a lot of system files, and each of those files have certain function that helps the Arista device to function properly. And if you look at this list, at the end you will see so-called zero-touch config file. Let's go ahead and open this file or view this file and see what it consists of. So I'm gonna say cat, and as you can see, disable is true. So when we run the zero-touch disable command, this file has added this entry to make sure that ZTP's function has been disabled. So this is another way how you can see this command, how you can see the result of your command here on the Linux level. So okay, in this directory, because it's safe to store everything here, because after the reboot, the content of the flash directory will stay untouched, unlike other directories, right? You have two directories where you can store your sensitive data, the flash and drive, and those are safe places to store, because after any kind of reboot, any amount of reboot, the file states will be untouched, right? So that's what I want. I don't want my scripts to get lost. So I'm going to go ahead and create a directory where I will store my scripts. So let's say make directory, let's say Arista, no, let's say like net DevOps. Cool. Let's switch to our newly created directory, and in this directory we can actually store our scripts, right? So I'm going to go ahead and say nano, and let's put test.py. I'm going to copy my code and paste right here, and let's just run it directly, I think. So I'm going to save it. I'm going to check if I have Python installed on it, which I should have. I have, but this is the old Python. Let's check if we have the new one version. Perfect. We have Python 3.9.17 version, which is pretty recent, actually. I mean, 3.12, I think, is the recent one now, but it's not that old, which is good, which is very good. So let's try to run our Python script using Python 3. I'm going to say Python 3 and indicate the name of our script, and syntax error, missing parentheses in the call to premises parentheses. Okay, I understand what's the problem. The problem is this is the format for Python 2, but I don't really need it, so I'm just going to go ahead and, yeah, run it in this fashion. Okay, I don't really understand what's going on. Maybe it's because of... Okay, so let's just delete all this bloat. We don't really need this. Let's just do it like this. It's much better. Okay, so I've changed only the last line. So I should use nano to go to last line and Control K, paste. That pasted the entire thing. Okay, whatever. Let's just delete this real quick. Okay, save. Now let's try to run it again. Missing parentheses. Oh, I think I didn't. I haven't saved it. I haven't saved it again. I'm gonna delete this. Maybe I just forgot to copy it. I wasn't really attentive to that part. Okay, now it looks better. So Control X. Yes. Good. Perfect. Now it works. I've ran the script, and as you can see, we've fetched MAC address of the device successfully. That's good. So this is what we call on-box usage of Command API. It is often useful to run scripts that use Command API directly on the switch itself without configuring them with AAA credentials. So we don't even need AAA credentials, right? This is a very important part. The reason why we can run it without configuration is because it does not need username or password or any other type of credentials to establish a session because we're already on the box, right? Okay, so other methods which require configuration, let's go ahead and explore them. The first is an HTTP server bound to localhost, which only accepts connections arriving from the same machine, and the other solution is a Unix domain socket. Okay, let's try to configure this. We're going to go back to Management API HTTP command section, and we're going to run these two commands to enable these options. Let's just go ahead and do that. So I'm going to open another session for convenience. Arista. Good. And let's go to this section again, which is Management API HTTP commands. And if I hit the question mark, I will see that yes, there are some options. So we need to say protocol HTTP localhost, protocol Unix socket. So protocol HTTPS or HTTPS or HTTP, which one? HTTP in this case, but we can also say HTTPS. I think it's not a big deal. It looks like it is a big deal because the difference, yeah. So for HTTPS, we'll need to add certificate, which I don't have now. Configure SSL, which I also don't have to do now, I guess. Okay, let's go ahead and say localhost, right? And bound it to port. Do I have to specify the port or by default? Yeah, 8080 by default, good. We don't have to specify anything. And protocol Unix socket create, good, good. So let's just run show management API HTTP commands, and yeah, we have successfully enabled local HTTP server. It's running. There's no authentication required, and it's set to use port 8080. And Unix socket server is also running. So let's go ahead and try examples with this. Once command API is enabled, then you access via the local domain socket. Local domain socket. Okay, so this is what we have to specify, right? Let me see. Okay, cool. I think I understand what's going on. I'm gonna just copy this entry. So let's actually create another script, and let's name them accordingly. Let's name this one, let's say onbox.py, right? Create another one. Let's actually copy onbox.py. Okay, this another name. Let's say Unix socket. So we have two, right? Cool. Let's go to the Unix socket, and we just have to replace this part. I'm going to copy this, and yeah, I'm going to paste it right here. So switch variable, which points to, we don't have any other. Okay, cool. So we're still using the eAPI client library, and we're using this particular function, which is eAPI client. Now, I don't really see where we use it though. Like, if we go back, yeah, here we use it, but in this case, do we really need to use it or no? That's the question. Because from what I see, I don't really need this. So let's just MAC address. Let's just, Okay, let's try like this. I'm not sure. I mean, it's completely useless, but let's just try and see what's the problem with the script. The Python 3, Unix socket, name server is not defined. Okay, how do I define that? Which makes sense. Yeah, I mean, I haven't seen it, but once command API is enabled, then you access via local domain socket. Ah, the local domain socket. Do you mean, okay. This is interesting. So, you mean from the bash itself? That's what it means, right? Okay, let's try that. Let's actually try this. So, I don't need this variable, I guess. Let me just go to the bash and paste this command. Var run Unix var. So let me just see what's going on here. Should we have it here? Command, yes, it is here. Okay, so we have the file on our file system. So what's the problem? We have successfully enabled the Unix socket option. What is this server? Maybe, okay, cool, I got it. So we need to have the server function or method from the JSON RPC web. So this is the entry we needed. Yeah, that's what I was looking for actually. So let me just clear this. Okay, nano Unix socket, Control K, paste, good, save, yes, Python 3 Unix socket. List indices must be integers or slices, not string. Okay, I don't really understand how it translates the output, but for the sake of simplicity, I'm just going to print response because I just want to see entire output. So just show me what you have here. Okay, that's a list. Okay, so inside the list, we should have a dictionary which consists of everything we need, including the MAC address, but for some reason, we couldn't see it. Let me try to see what I can do here. So this is the first list, and on the list we have an element called MAC address. So this should be enough. Control X, yes, run again. What's the matter? I forgot the square bracket. Very impractical. Save again, run again. Key error MAC address. It cannot see the key because, because it's system MAC address. Yeah, happens a lot. So just system MAC address. Okay, now it should work. Cool, perfect. We fetch MAC address using the Unix socket option. So since we can successfully separate it, so let's go ahead and use the last option in our onbox usage section, which is the HTTP over localhost. And the same thing applies here. The only difference is instead of using Unix socket right here, we're going to use the HTTP connection to localhost via port 8080 by default. And let me just copy this. Let me go back to my device, bash shell, and let's just create, let's say HTTP access.py. Let's enter this file, and we just have to get rid of this part. Right. Okay, whatever. And let's just add some output for readability, I guess. And okay, Control X, yes, Python 3, HTTP access, perfect. Okay, so as you can see, guys, this was the unbox usage section of Arista's Command API tool. The unbox usage is great because we absolutely do not have to create or configure the users or passwords. So this might be useful exactly when you are having problems with your AAA servers or with your credentials in general. And although I don't really see this being useful in scalable network, in an extensive network, obviously, but we're starting to learn, we're exploring together. I mean, I'm new to Arista, as I said before. So today we successfully completed exploring the on-box usage of command API. We used eAPI's client lib, we used the Unix socket, right? And we used the local HTTP over localhost methods, right? And we actually utilized the switch's Linux shell, the bash shell, to execute scripts from the switch itself, which is very, very cool and efficient. And imagine how long we could extend it, what other things we could do in it. And I already have some plans and ideas. I'm sure you also do, because this is really, really extensible. Arista indeed justifies that its operating system is indeed extensible and robust. So for this video, I think it's enough. We explored some options. I don't want to make this too long. Thank you for watching this video. Again, subscribe for more content. If you have any questions, please put comment under the video. And if you have any recommendations as well, don't hesitate to comment it out. So see you in the next video. We'll proceed further and see what else we can do with Arista's automation options, which is so far very interesting. Thank you for watching again. Have a nice day.